Dear students, in the quantum mechanics lecture 1, we discussed about de Broglie hypothesis, expression for de Broglie wavelength in terms of kinetic energy of the particle, accelerating potential, and properties of matter waves. In addition to that one, we have discussed about group velocity, phase velocity. In the present lecture, we are going to derive relation between group velocity and phase velocity. We already defined what is phase velocity, what is a group velocity. From the definition of phase velocity, V phase equal to omega by k, where omega is the angular frequency, which is equal to 2 pi nu. Nu is the frequency. And k equal to wave vector or wave number, that equal to 2 pi by lambda. So from this relation, omega equal to how much? V phase into k. So omega equal to V phase into k. And from the definition of group velocity, we have derived V group equal to d omega by dk. Now we are replacing this omega with V phase into k. So if we differentiate this one, the first term, that is V phase, into derivative of second term dk by dk, that equal to 1, plus second term k into derivative of first term, that is dV phase by dk. So this will come like this. But the k depends on wavelength lambda. That's why we have to derive this relation in terms of lambda. That means you have to replace k with lambda. For that, how we will manipulate this equation is, see here is C, V group equal to V phase as it is, k as it is, dV phase by dk we have written as dV phase by d lambda into d lambda by dk. So now we have to find out this d lambda by dk. And k value we all know 2 pi by lambda. So if you replace these two values, you will get the relation between group velocity and phase velocity. Further, we will start with k. We know k equal to 2 pi by lambda. So differentiate with respect to lambda, then dk by d lambda. So if you take dk by d lambda equal to 2 pi is constant, then d of 1 lambda by d lambda, that equal to minus 1 by lambda square, because we know d by dx of 1 by x is equal to minus 1 by x square. You already studied about this relation. You all know about this one. D by dx of 1 by x equal to minus 1 by x square. This value you already know. So from this, if you take here dk by d lambda, 2 pi is a constant. So d by d lambda of 1 by lambda equal to minus 1 by lambda square. So take the reciprocal of this one. Then d lambda by dk equal to minus lambda square by 2 pi. Now you take the k value equal to 2 pi by lambda and d lambda by dk equal to minus lambda square by 2 pi in the previous equation. This is the previous equation. Here we replace k with 2 pi by lambda. Then d lambda by dk with minus lambda square by 2 pi. Then you will get the final relation, that is a relation between V group and V phase. So now k equal to 2 pi by lambda and d lambda by dk equal to minus lambda square by 2 pi. Now this 2 pi will cancel, this lambda square will cancel. Then the final equation becomes V group equal to V phase minus will come here, lambda will come here. So V phase minus lambda into dV phase by d lambda. This is a relation between group velocity and phase velocity. If the question asks, derive the expression for write the group velocity in terms of phase velocity, means you have to use this relation. You have to derive this equation. Okay, and next we are going to prove the group velocity is equal to particle velocity. We are going to prove group velocity is equal to particle velocity. So now we are going to prove V group equal to, that is group velocity is equal to particle velocity. We already defined V group equal to d omega by dk. So omega is the angular frequency, k is the wave vector or wave number. This is 2 pi by lambda, this is 2 pi nu, that are 2 pi f. F is the frequency. So we can write omega equal to 2 pi into f. So then we know E equal to h nu or hf, h into frequency. From this, what about frequency? Frequency equal to V by h. So now we are replacing this frequency with V by H. Then the omega equal to 2 pi into V by E by H. So if you take the d omega, the omega changes with E only because 2 pi remains constant, H remains constant. There is no change in the 2 pi by H. There is only change in the E. The change in E gives the change in omega. So if you take d omega equal to 2 pi by H into dE. So d omega equal to 2 pi by H into dE. Again, we know k equal to 2 pi by lambda. We already discussed that. So k equal to 2 pi by lambda. We know where is the, sorry, lambda is the dipole wavelength. Lambda equal to h by t or h by mv. That mv is the momentum t. So this p will come here. So 2 pi p by h. In this case, the change in k occurs with change in p because 2 pi by h remains a constant. Therefore, if you take dk equal to 2 pi by h into dp. So dk equal to 2 pi by h into dp. So here d omega equal to 2 pi by h into de and dk equal to 2 pi by h into dp. So substitute these two values d omega here and dk value. So substitute there. Then you can get a V group equal to E by dp like this. So d omega equal to 2 pi by h into de and dk equal to 2 pi by h into dp. So the 2 pi by h, 2 pi will cancel. Therefore, V group equal to dE by dp. We know the E is the kinetic energy equal to half mv square. If you multiply numerator and denominator with m, so then if you multiply here numerator denominator with m, then what will get? M square V square by 2m. So if you multiply numerator denominator with m, then what will get? M square V square by 2m. So m square V square means mv whole square. So we know mv is nothing but momentum. So we can replace mv with momentum. So for mv whole square equal to v square by 2m. So we can write the kinetic energy equal to p square by 2m. So we can write kinetic energy equal to p square by 2m. So E is the value of p square by 2m. Then differentiate this one with respect to p. Then d by dp of E, that is means d by dp of p square by 2m. So 2m is constant, that will come out. D by dp of 2p square. D by dp of p square is much 2p. So d by dp equal to here E replaced with p square by 2m. So 1 by 2m constant. D by dp of p square equal to much 2p. Therefore 2 will cancel. Then p, we know p is nothing but momentum. So momentum nothing but mass into velocity of the particle. So m into v particle. Then m will cancel. Then dA by dP equal to how much? V particle. But dA by dP equal to how much? The group velocity. Therefore, group velocity equal to d omega dk. D omega by dk equal to dA by 2p. dA by dP equal to V particle. So in this way, we can prove V group equal to V particle. So V group equal to V particle is proved. That means group velocity is equal to particle velocity. One more relation we are going to do now, that is V group into V phase equal to C square. So the product of group velocity into phase velocity equal to C square. In that we have to remember, we already proved V group equal to V particle. For this we will take a phase velocity, V phase equal to omega by K, we all know. So in this omega equal how much? 2 pi f. F is nothing but E by H, we already discussed in the previous topic also. So from this omega equal to 2 pi into E by H or 2 pi by H into E. So if you take K equal to 2 pi by lambda, this is also we discussed in the previous concept. And lambda equal to H by P. Therefore, K equal to 2 pi P by H or 2 pi by H into P. Now, in the definition of V phase equal to how much? Omega by K. So we are replacing omega with this value and k with this value. Therefore, V phase equal to omega by k, omega equal to 2 pi into V by h, k equal to 2 pi by p into, 2 pi by p by h. So 2 pi will cancel, h cancel. Therefore, V phase equal to E by P. Therefore, V phase equal to E by P. We know according to Einstein mass energy relation, E equal to mc square. And we know from the definition of momentum P equal to mass into velocity of the particle. So now m will cancel. Then c square by v particle. We already proved v particle equal to v group. So we already proved v particle equal to v group. So now we are replacing this v particle with group velocity v group. So if you replace this one, then v phase equal to c square by vg. So v group, v phase equal to c square by v group. So then v phase into v group equal to c square. V phase into v group equal to c square. So these are the relation between group velocity, phase velocity, and particle velocity. Next, very important concept, that is Heisenberg uncertainty principle. What is Heisenberg's uncertainty principle? It is impossible to measure a pair of conjugate physical variables simultaneously to a desired degree of accuracy. What is the meaning of that one is, if you take a conjugate physical variables, for example, position x and momentum p. These are one pair of conjugate physical variables. These two quantities we can't measure exactly at the same time. That means if you measure x exactly, there's a lot of uncertainty in the momentum. If you measure momentum exactly, then a lot of uncertainty in its position. So if you want to measure any one quantity exactly, then we are getting the lot of uncertainty in the other quantity. So this statement is given by Heisenberg, that is known as Heisenberg uncertainty principle. That is, it is impossible to measure a pair of physical quantities simultaneously to a desired degree of accuracy. For example, if delta x is the uncertainty in the location of position of momentum, and delta p is the uncertainty in the momentum measurement, then the product of these two in the order of h cross by 2. H cross nothing but h by 2 pi. H is the Planck's constant. So if uncertainty in the position is delta x, uncertainty movement is delta p, then delta x and delta p in the order of h cross by 2. What is h cross? H by 2 pi. So then delta x delta p is h by 4 pi. Similarly, you can define the same relation with another pair of conjugate variables, for example, energy and time. That is delta E into delta T in the order of h by 4 pi. Or angular momentum and angle, that is J and theta. So you can define delta E, delta T product is in the order of h by 4 pi, energy and time. Like that, angular momentum and angle is also another pair of conjugate field variables. So one of the example, that means one of the application of this uncertainty principle we are discussing in this topic, that is non-existence of electron inside the nucleus. So now we are going to discuss about one of the application of Heisenberg uncertainty principle in the present topic. So in that we are going to prove electron not exist inside the nucleus. Non-existence of electron in the nucleus. Why this confusion comes here? Why electron exist in the inside the nucleus? Why they assumed there? Why this confusion and why the issue of existence of electron inside nucleus comes here is, if you take any radioactive nuclei, that is uranium or plutonium, anyone, so from nucleus of these radioactive materials, what we are getting alpha particle, we are getting beta particles, and we are getting gamma particles. Alpha, beta, gamma particles are coming from this radioactive nuclei. Alpha particle nothing but helium nuclei. It is having two protons and two neutrons. Two protons and two neutrons because nucleus is having protons and neutrons. So at the time of emission of alpha particle, two protons and two neutrons they are forming as a alpha particle and they can come out of the nucleus. That is possible. And gamma particle is nothing but photons. Photons are emitted due to the moving of these nucleons. That means protons or neutrons are moving from the one energy level to other energy. They are jumping from the higher energy level to lower energy level. They can emit the photons. So gamma particles are, can also comes like that. But beta particles are nothing but electrons. If electrons are not exist, how they can come out of the nucleus? That's why they got it out. The beta particles are coming means electrons are exist inside the nucleus. But Heisenberg-Gansen principle proved that electron does not exist inside the nucleus. If electron does not exist inside the nucleus, how beta particles are coming? That we will discuss at the end. First, we will prove electron does not exist inside the nucleus. So, to prove that one, so what we will do now, we will assume electron exists inside the nucleus. What we will do here? Electron exists inside the nucleus. If electron exists inside nucleus, for example, this is the one nucleus I am showing in this two-dimensional pattern here. So this is actually a spherical shape. You take a nucleus here. The radius of the nucleus is 10 power minus 14 meter at about in the order of 10 power minus 14 meter. So let us take a nucleus. The radius of the nucleus in the order of 10 power minus 14 meter. Then if electron exists inside the nucleus, if it is there inside the nucleus, what is the maximum uncertainty in the location of position of electron? The maximum possibility is only radius of the nucleus. That is in the order of 10 power minus 14 meter. There is no chance to have the uncertainty more than that value. So the maximum uncertainty in the location of position of electron inside the nucleus is how much? Radius of the nucleus, that is at about 10 power minus 14 meter. So if you take delta x maximum is 10 power minus 14 meter, then according to Heisenberg-Gansen principle, delta x maximum to delta p minimum equal to h by 4 pi. Delta x maximum to delta P minimum is equal to h by 4 pi. From this, we can find out the P minimum. So delta P minimum. So delta P minimum equal to h by 4 pi into delta x maximum. So delta P minimum equal to h by 4 pi into delta x maximum. So substitute the delta x maximum here. And h equal to 6.625 into 10 power minus 34 joule second. And pi value 3.14. Substitute all those values here. What we will get for delta P minimum 0.528 into 10 power minus 20 kg meters per second. So if delta P is the minimum uncertainty in the momentum, then what is the P min value? What is the minimum momentum value? We know uncertainty definitely not more than the actual value. So actual value always more than the uncertainty. So that's why there is no chance to have the momentum value less than delta P minimum. So the P minimum definitely is equal to delta P minimum. So we can consider the P minimum equal to delta P minimum. So by taking this P minimum value, we can find the minimum energy value. To find the minimum energy value, we are using relativistic energy formula because with this momentum, the electron is moves with velocity almost in the order of velocity of light. In that velocity range, the classical theory will not work out. Newtonian mechanics will not valid. That's why we have to take the relativistic kinetic energy formula. So the relativistic kinetic energy formula is this one, E equal to square root of m naught c square whole square plus pc whole square. Is the m naught is the rest mass of the electron, c is the velocity of light, p is the momentum of the electron, c is the velocity of light. By substituting these values, you will get the minimum kinetic energy of the electron. So we have substituted rest mass of the electron is 9.1 into 10 power minus 31 kg, and C velocity of light is 3 into 10 power 8, and minimum momentum we have obtained here is this value, and velocity of light is 3 into 10 power 8. So by substituting all these values in simplify, you will get the minimum kinetic energy is 9.98 mega electron volt. That means if electron exists inside the nucleus, what is the minimum energy of electron? That is around 10 mega electron volt, 10 MeV. So it is not possible to have the energy less than this value. That means if beta particles are, that means beta particles are electrons. So electron is just inside the nucleus. Then beta particles are emit with energy around 10 mega electron volt. But the energy of the beta particles are 3 MeV approximately. So that means here the beta particles are not coming as an electron because of existence of electron inside nucleus. They're coming as electron because of conversion of neutron into proton and electron. So inside the nucleus, a neutron is converted into proton and electron. Proton remains inside the nucleus and electrons are emitted as a beta particle. So electron does not exist inside nucleus, but beta particles are electrons because of conversion of a neutron into proton and electron. Proton remains in the nucleus and electron is coming out as a beta particle. So in the lecture 3, we will continue the remaining discussion. We will stop it here. Thank you.